The relation between time t and distance x is t is equal to ax square plus bx. So this is t is equal to, where a and b are constants. Then the acceleration is. The reason why I have selected this question as the first one in the topic acceleration is due to the fact that this question has almost many connections with the previous topics, that is instantaneous velocity. We did 10 questions on instantaneous velocity, and almost all of them had some elements of differentiation or integration. Now, when it comes to this particular question, what we should understand is it is differentiation and integration that we're going to use in this question, but what's given in the question is slightly different from what we were exposed so far. Let us see how and let us see why. See, what's given in the question, it says that t is equal to ax square plus bx, right? Now, you should keep in mind that the question has demanded it is t and not x as a function of time. So earlier we were given displacement time relation, right? Displacement time relation. But now we have been given time as a function of displacement. Okay. Now, if I differentiate this, what do I get? Differentiate with respect to time, what do I get? D by dt of ax square is 2ax and bx is b, right? No, it is not the case. See, that is what I was trying to convey. Mind you, guys, when we say it is derivative of, when we say derivative of ax square with respect to t and derivative of bx with respect to t, it is not 2ax. Then what is it? It is basically 2ax times dx upon dt. Very similarly, plus bx is not b, the derivative of bx with respect to t is not b alone, it is b into dx by dt. You have a doubt, I'll make it clear for you. Simple. It goes like this: d by dx of x square is 2x, but d by dt of x square should be 2x dx by dt, provided t and x are functions based on this. Okay. Now, in this case, if dt by dt 1 is equal to 2ax, right? So let us continue the question from this step. So we've been given that 1 is equal to 2ax into dx by dt plus b into dx by dt. Now, what will happen if I take dx by dt common? What is left in the bracket is 2ax plus 1 times dx by dt. Now, what can we write dx by dt as? So, dx by dt will be 1 by 2ax plus 1, right? Which means velocity. Okay, let me write this separately. Which means velocity is basically 1 by 2ax plus 1. But what is being asked in the question? The question is to find out the acceleration. Now, if velocity is 1 by 2ax plus 1, what can we say about acceleration? Acceleration would be the rate of velocity, which means it should be derivative of 1 by 2ax plus 1. Now, if you want to understand the differentiation of this fraction, please make sure you follow the video on mathematical tools, basic differentiation integration. I've given a two video series completely dedicated, one on differentiation, another on integration. So those people who have done that session would be able to understand that this is basically minus 1 by 2ax plus 1 the whole square times 2a into dx by dt. Okay. Now, this would further be equal to, let me just make a small rearrangement here. Let me put minus here, minus 1 here, times 2ax plus 1 the whole square into 2a into what is dx by dt? See, dx by dt is basically v, right? And what is 1 by 2ax plus 1? See, it is given that, no, we just derived that velocity is 1 by 2ax plus 1, right? So if you just take out this value and substitute over here, what do we get? We get that this is equal to minus 1 into v square into 2a into v, right? Because this whole portion 1 by 2ax plus 1, 1 by 2ax plus 1 is v, which means 1 by 2ax plus the whole square will be equal to v square, which further means that acceleration is equal to minus 2a v cube. So the correct option to this question is option B.